Okay, so today I'm going over factoring using the AC method, which is the preferred method for most people and one that I recommend if you just don't like to do the guessing and checking method. So what exactly is factoring? We have to look at what the word factor means. A factor is a number or quantity that when it's multiplied with another number or quantity, like 2 times 8, it gives you something else, basically. 2 times 8 gives you 16. So 2 and 8 are considered factors of 16 because they multiply to get to that larger number. So factoring is reversing this process of multiplication, and we're taking a single thing and splitting it up into things that are multiplied together. So if you had the number 16, you would factor it by splitting it up as like 2 times 8, maybe 4 times 4. There's lots of ways you can factor that. When you involve variables, there's pretty much only one way, although the order that you write them it might be different, but there's pretty much only one way it factors, and it's reversing the distributive property. You know, when we multiplied polynomials together and did FOIL, factoring is undoing that. So it's splitting it apart so that you've got these things that are multiplied together. So some things you need to know in order to learn the AC method is first the greatest common factor, which is abbreviated GCF. And this is just the largest factor that is in common to a series of terms. So if you have a whole list of number, it's the biggest number that you can divide into all of them. So if I have, let's say the numbers 10 and 15, and then let's say 30, the greatest common factor is 5, because that's the largest number I can divide into 10, 15, and 30 without getting a remainder. When you have things with variables, your greatest common factor is the variable that has the smallest exponent. So if you have things like x squared and then x to the 5th, x squared is your greatest common factor because that exponent is smaller. Out of 2 and 5, 2 is a smaller exponent. The second thing you need to know about in order to learn the AC method are binomial factors. And so these are factors that you have more than one term. So you will have parentheses around something like x plus 2. So the parentheses are telling you that this thing is like combined. You can't split it up. You're not looking at it as an x and a 2 as two separate things. It's one thing, x plus 2. And you may see things with exponents on these, like maybe you'll have an x plus 2 squared and an x plus 2 to the 3rd, and you'd want the one with the smallest exponent. But most of the time when you're doing the AC method, you're not going to have exponents on these. You're just going to have a binomial factor, something in parentheses that everything has in common. So that brings us to factoring using the AC method. So this works only if you have trinomials, which is 3 terms. So I'll write that down, 3 terms. And it's in the form ax squared plus bx plus c. So it has to be quadratic. You have to have that highest exponent be a 2, otherwise it doesn't work. And we're going to be factoring out greatest common factors and binomial factors. Now, I mentioned this before, one of the benefits why this is the preferred method is you don't have to guess and check as much. You do have to do a little bit, but not as much as you would have to do if you were using the trial and error method. But the other downside is it does take up more work on your paper. It's not harder, it's just got more steps to write down because instead of trying to do it all in your head, you're doing it on paper. So that is the downside, but I personally think that this is far superior. For most factoring, if it's not something that you can just instantly see the answer to. So there are several steps. You're going to want to have this written down, try to follow these steps, have this handy. So you first need to have your trinomial in the form ax squared plus bx plus c. Variables could be y, they may not be x, but it's in that form. Your first step is always to factor out the greatest common factor if there is one. There's not always a greatest common factor, but there is. If there is, that's the first thing you do. Then you look at what's remaining after you factor that out. And so you take the first and the last term coefficients, the a times the c, you multiply those together. Then that gives you a new number, and you're looking for two numbers that multiply to that new number, and that when you add the numbers together, you get to the middle number, b. So it's similar to when you're factoring by guessing and checking, you're multiplying it to one number, adding to the middle. But it's just instead of multiplying to c, we're multiplying to a times c. So we're including that first number in front. Then you are rewriting the middle term. So the middle term is no longer, oops, that's a typo. That should be a c right there. The middle term is no longer going to be plus bx. It's going to be plus something. And those are going to add together to be bx. So we're taking that middle term and we're splitting it up into two pieces. And it's still equal. Up and here I go. I'm copying down. I did a lot of copy and pasting, so I missed my b, kept writing, or missed the c, kept writing it as b. So we're splitting this bx into two pieces. It's still equal to what it was, but we're doing this specifically so we can factor by grouping. And so the factor by grouping process is then what you do once you have four terms. And so I've got the 4 steps for that process right here. First is you group the first 2 terms together and the last 2 terms together. Then you factor out the greatest common factor for each pair. They may not be the same number. It may be a different greatest common factor. Then you simplify inside those sets of parentheses, and that will give you your binomial factor. So you can see I said that you're going to need the greatest common factor and binomial factors. You will get 2 things in parentheses that match, and it will be a binomial. And then you factor out the binomial factor when they match, and if you've done this correctly, they will match. And then that gives you your final answer. You'll have your binomial factor in front, and then the greatest common factors for those 2 groups are going to be the second part of your final answer. So let's see this in action. I'm starting first with not having a number in front of the squared term. You know, we're going to start simple. We're going to kind of work our way up. So we're going to use the AC method to factor y squared minus 6y minus 40. So if there's no number in front of your y squared, you treat it as a 1. So, and there's no greatest common factor here to divide out either because there's no number in front of the y squared. So we can skip basically the first step. And so we're going to take a, which is equal to 1, and c, which is equal to negative 40, and we're going to multiply those together. So ac is 1 times negative 40, so that just gives us negative 40. So the next step is you want to find 2 numbers that multiply to negative 40, and they need to add to negative 6. So we're now looking at this negative 6 right here. That is our b. b is negative 6. So I ignore the sign of AC to begin with. I ignore the fact that it's negative 40. I just will look at 40. And I'm going to write down every combination of pairs of numbers that multiply to 40. So 1 times 40, 2 times 20, 3 doesn't, 4 times 10, 5 times 8, 6 doesn't, 7 doesn't, and then I'm back at 8 again. So I just kind of go through in my head my multiplication table. You could also do this on a calculator, and you're only looking for the pairs that actually multiply to that. And then I'm going to look at my sign here. So I'm multiplying to a negative, which means one of these has to be negative, because a positive times a negative is a negative. The middle term is negative, and what that tells you is that when you're looking at the pairs of numbers, the biggest number has to be negative. So because my b is negative, that tells me that the larger of these numbers is negative, and so that tells me where do I put my negative sign. So I'm looking for the combination that adds to -6. So 1 and -40 gives me -39, 2, -20, that's -18, 4, -10, that gives me -6. So I'm going to circle that. That's our matching pairs of numbers, 4 and -6. Those combine to give you, or 4 and -10, they combine to give you -6. So, oops, whoa, why did my, I don't know why that just did that. So I'm going to take my expression to rewrite it here. I have my y squared, and instead of writing -6y, I'm going to take my pairs of numbers here. I have 4, so that's going to be plus 4y, and then I'm going to put another plus, then plus -10y. So I have that y there because my middle term has y, and then I have -40. So we have just taken that middle term and split it up so that now we have 2 terms. And then we group them together, and you want to make sure when you group them you have a plus sign in between. So that's why instead of writing -10y, I wrote plus -10y. So you have to have a plus in between these 2 groups. Then we want to find the greatest common factor for each pair. So if I look at the first pair, I have y squared plus 4y. My greatest common factor I can factor out is a y. So that has the smallest exponent, basically no exponent. The second group, if your first thing in the second pair is negative, you're always going to factor out a negative. And then I can divide them both by 10. So I have 10 and -40, basically, -10, -40. I can divide those both by a -10 here, but I can't remove a y because there's no y in the -40 to remove. So these are my greatest common factors. So once you've identified these greatest common factors, you rewrite, so you've got your GCF in front, and then you divide each term by your GCF. And you could do this in your head. You don't have to write this step, but when you're just learning, it's very handy to write this step to kind of double check yourself. So the first set I was dividing by y, but the second set I'm divided by -10. And notice how I turned that -40 into plus -40. So that way I made sure I had a plus in between each of my parentheses. So I've got my GCFs basically in front, and then I'm also dividing each pair that we have by the GCF. Then we simplify. So the y stays outside, and then I'm going to be removing y from each of these fractions. Basically, if I have y squared, that's 2y, so one of them's gone. Then the y cancels out, and so I end up with y plus 4. Then I have y plus -10. And then I'm dividing these all by -10. So a -10 times divided by a -10 is 1, so I'm left with just a y left over. And then -40 divided by -10 is a positive 4. So notice inside the parentheses here, we have binomial factors. They're binomial, things in parentheses, 2 terms in there, and they match. And that's what we want to do the AC method. So we take what's matching there, and that is our first factor, y plus 4, and that goes in front. And then in the back is what's left over when you remove that. So we have a y plus a -10. And that's your answer. That is the AC method. Now, on this particular problem, I would have just used guess and check here because it's easy enough to get that same answer just by guessing and checking. But you can do the AC method on it. And I use the AC method whenever I have numbers in front of the y squared because it just makes it easier for me. So, second example here where we do have a number in front of the y squared. We've got 16y squared plus 14y plus 3. So there's no greatest common factor to factor out. There's nothing in common between 16, 14, and 3. So we start by multiplying a, which is 16, by c, which is 3. So a times c is 16 times 3, which gives us 48. And now we want to add to the middle. We need to get that to 14. So I'm going to write down all the two numbers that multiply to 48. I know I've got 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 doesn't go into 6 times 8, 7, and then I'm back to 8. So I've got all of my choices here. And in this case, we're multiplying to a positive and adding to a positive. So both of these numbers are going to be positive. So I'm just looking for the pair that gets me to 14. And so you try to add those, and it ends up being 6 plus 8 will get me 14. So I'm going to rewrite this as 16y squared plus 6y plus 8y, then plus 3. So instead of writing plus 14y, I now have 6y plus 8y. And then we're going to pair these off by grouping the first two and the last two things. And then we're going to find the greatest common factor. So between 16 and 6, I can't divide them both by 3 or 8 or 4. I can divide them both by 2. So that's the largest thing I'm going to be able to get out of there. I can also remove a y from both of those. For the second pair, I have 8 and 3. I can't remove a number. And between y and nothing, I can't remove anything. So if you get to a point where there's nothing you can take out, just write a 1. There is no greatest common factor. There's nothing I can divide out of there. So you just write a 1. So once I've identified those, I'm going to factor them out. So I'm going to put the GCF in front and then divide each term by the GCF. Make sure there's a plus in between, and then I've got that 1 in front, which seems kind of silly here, but we're going to go through the process and divide everything by 1. And so I'm going to simplify inside the parentheses. 16 divided by 2 is 8, and then I removed a y, so now I'm left with 8y plus 6 divided by 2 is 3, and the y is canceled, so I get 8y plus 3. Then plus 1, and then I'm just dividing by 1, so everything stays the same. So I have 8y plus 3 again. So then you can see that in parentheses, our binomial factors match. And that's good. That's telling you that you didn't make any mistakes. So that's our first factor, 8y plus 3. And then the second one is what's in front, 2y plus 1. And so that's your final answer. And this is where you may be preferring to do the AC method versus trying to figure out the combination of numbers that multiply to 16 and multiply to 3, and then getting some sort of combination to get to add to 14. It's a little harder to do that because you've got many, many combinations. Doing the AC method, you only really have one combination you're worrying about. Okay, so we're going to use the AC method to factor negative 14y squared minus 50y minus 24. So we're graduating up to now we have a greatest common factor to factor out first before we do anything else. So there is a number I can divide out of all three terms. First off, I can divide a negative. If that first term is negative, always divide out a negative. Then I'm looking at 14, 50, and 24. I can divide those all three of those by 2, and I believe that's the largest thing that I can divide out. So I can factor out a negative 2. So that's going to be a negative 2 in front. And then I'm just dividing each term by negative 2. And every time I have a minus, I rewrite that as adding a negative so that when I do this division process, I don't mess up the signs. So this gives us negative 2 times 7y squared plus 25y plus 12. So now we're going to use the AC method on what's inside the parentheses. So I'm going to take the 7 and the 12 and multiply those together. Which 7 times 2, 14, 7, 84. And so now I want to find the combination of numbers that multiplies to 84 and adds to 25. So there may be a lot. It's going to be 1 times 84, 2 times 42. This one's harder to do in my head. 84 divided by 3. Okay, so that's 3. 28. 84 divided by 4. 4 times 21. 84 divided by 5 is decimal. 84 divided by 6. That's 6 times 14. 84 divided by 7, 7 times 12, I should have known that, that's right up there. 84 divided by 8, decimal. 84 divided by 9, decimal. 84 divided by 10, decimal. 84 divided by 11, decimal, and then I'd be dividing by 12, and I'm kind of going back up my list again. So that's all of them. We're multiplying to a positive 84. We're adding to a positive 25. So all of these are going to be positive. So I'm going to just put a plus sign in between there. And we're looking for the pair that adds to 25. So you just go through your list and you find that 4 plus 21 gives you 25. So now when we rewrite this, this is slightly more difficult because we have this GCF in front, so we need to keep that there. I've got my 7y squared. Then instead of 25y of plus 4y plus 21y, then plus 12, make sure I'm writing down the right numbers there. So it's going to get a little confusing with all of the parentheses, which is why I like to kind of color code. So when I'm grouping here, I'm grouping inside existing parentheses because of that first GCF that we took out. So I'm looking at the 7y squared and the 4y. So our GCF, there's no number between 7 and 4, nothing in common there, so I can factor out a y. And then in the back, 21y plus 12, I can divide those both by 3. If the greatest common factor thing is kind of confusing for you, I do have a video going through the greatest common factor. And so you may want to review that if you're kind of getting stuck on this process. So I need to rewrite that -2 out there and then the parentheses. And then inside the parentheses, I've got my y times, and now I'm dividing by the GCF, 7y squared divided by y plus 4y divided by y. So you can see you're going to kind of get lost within all the parentheses here. So it's very careful. You want to make sure you close them, color code, whatever you need to do to keep track of them. Oh, I forgot to write my GCF in front. 3, then parenthesis, then 21y divided by 3 plus 12 divided by 3. So I get a -2 still in front. Keep the first parenthesis. Then I have y and then parenthesis. And when I simplify, it look like a better parenthesis, 7y squared divided by y is going to give me 7y plus, then the y's will cancel. I'm left with 4. Then I have plus 3, parenthesis, 21 divided by 3 is 7, so I have 7y plus 12 divided by 3 is 4. Close both parentheses. And so now you can see, and I'm going to highlight this, that our binomial factors are matching, which is good. Now normally that would go in front, but we have this -2, so that actually goes in front first. Then I have my 7y plus 4. And then I have the leftovers, which is y plus 3. So that -2 that we initially pulled out just has to keep hanging on for dear life as we go down and down and down through this process. But it follows all the way down, and then we finally get to our final answer where that -2 hangs out in front. So I'm actually going to skip my next example, and let's do this one. So I've got 9y cubed minus 30y squared plus 24y. So this has a greatest common factor that we have to come out first, have to factor it out first, because it's not quadratic right now. So out of 9, 30, and 24, 9 doesn't go into those, but 3 does. So I can divide them all by 3. And then they all have a y. We've got a y cubed, a y squared, and a y. So y has the smallest exponent. So the greatest common factor is going to be 3y. So I'm going to factor out 3y. So I have that in front, and then 9y cubed divided by 3y plus -30y squared divided by 3y plus 24y divided by 3y. Simplify, I have 3y in front, 9 divided by 3 is 3, and now I'm left with y squared because I removed one of them, I divided it out. Then -30 divided by 3 is -10, so that's plus -10y. And then 24 divided by 3 is 8, and the y's cancel, so we're left with 3y squared minus 10y plus 8. So now that we've taken out the greatest common factor, we're going to take a and c. So a times c is 3 times 8, which is 24. So we're multiplying to 24. And then we want to add to -10. So I'm just going to write down 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then we start repeating again. Now, in this case, we're multiplying to a positive but adding to a negative. So the only way for that to occur is if you have two negatives, because a negative times a negative is a positive, but two negatives add to another negative. So both of these sets of numbers have to be negative. So now that I know they're both negative, I'm looking for the pair that when I add them together gets me negative 10. And so that's the last one right here. Negative 4 minus 6 is negative 10. So I'm going, if I can get my color coding, my pen does not want to change color. Oh well. Okay, so it doesn't want to change color, so it'll just stay. I've got 3y, and then I'm rewriting the middle. 3y squared plus negative 4y plus negative 6y, then plus 8, and then close my parenthesis. Of course, now I can get it to actually work. Oh, I'm not touching anything, and it just did that on its own. Okay. So I've split my middle term up, the negative 10y, into negative 4y plus negative 6y. And now I want to group. And remember, when you group, you need to have a plus sign in between. And that's why I write every subtraction here as adding a negative. So my GCF in the first pair, I can't divide a number out of 3 and negative 4, but I can remove a y. And you'll see in that first pair, you're always going to be able to remove a variable. And then generally in the second pair, you never get to remove a variable. So out of negative 6 and 8, I can divide those both by 2. And actually I want to divide by negative 2 because the first number in the pair is negative. So I've got 3y, and then sometimes it helps people, instead of using parentheses on the outside, to use brackets just so they don't get so confused. So I'm going to use a bracket there. Then I've got y parenthesis, and then I've got 3y squared divided by y plus negative 4y divided by y, and then plus, and then the next GCF is negative 2. Then I have negative 6y divided by negative 2 plus 8 divided by negative 2. And then I can close my bracket. And then I've got my bracket, my y, and I simplify. So one of the y's cancel. You're left with 3y plus negative 4. And then I have my plus negative 2, then negative 6 divided by negative 2 is a positive 3, 3y plus 8 divided by negative 2 is negative 4. And to double check, always double check that your parentheses match. They need to have the same numbers and the same sign, so they both are a positive 3y and a negative 4. And so this brings us to our final answer. We're going to have 3y in front. Then we're going to have 3y minus 4. And then the leftovers are y minus 2. As you can see, this is a very, like, you're going through the process, you're kind of doing the same thing over and over and over again. So doing more of these, you're going to keep practicing, you're going to get better at this because it's the same procedure over and over and over again. So this one's different because we've got two variables here. But we can still use the AC method because it's quadratic and it's a trinomial. So we've got 20a squared plus 3ab minus 9b squared. So there's no greatest common factor here out of the 20 and the -9 and the 3. I can divide something out of 3 and -9, but not the 20. And I can't remove any variables. There is no greatest common factor. So I'm going to just start with our first number, which is 20, and the last number, which is 9. So it's in the right form. And we're going to do 20 times -9, which is -180. And then we want to get a pair that adds to 3. So we're going to write down, we've got 1 times 180, 2 times 90, 3 times 60, 4 times 45, 5 times, starting to pull out my calculator, 36, 6 times 30, 7 gives me a decimal, 8 gives me a decimal, 9 times 20, I should have known. We've got 10 times 18, divided by 11 as a decimal, 12 times 15, and then, let's see, 13 decimal, 14 decimal, and then I'm back to 15. So a lot of choices here. A lot of choices. We're multiplying to a negative and adding to a positive. So the last time we were multiplying to a negative, we needed one number that was negative, one number that was positive. We're adding to a positive. This tells us the bigger number is positive. And that means the smaller number is negative. So last time we were adding to a negative, so the big number is negative. In this case, the smaller number is negative. So the big number gets whatever the sign is in the middle. The other one gets the opposite sign. And now we're looking for the combination that gives us gives us 3. These have to add to 3. So you just go down the list until you get to the pair that adds to 3, which is the last one on the list, -12 and 15. So when I rewrite this, I've got 20a squared plus -12. And then because the middle is AB, I'm going to put AB there. So whatever your variable is in the middle, that's the variable you use. Then I have plus 15AB, and then plus -9b squared. So I'm going to group the first two and the last two and make sure there's a parenthesis in between. Greatest common factor. Out of 20 and 12, I can divide those both by 4, and I can also remove an A. I can't remove a B because the first term doesn't have one. The second pairing, 15 and 9, I can divide them both by 3, and I can remove them both by B. So those are my GCFs, so I'm going to rewrite. I've got 4a parenthesis 20a squared divided by 4a plus -12ab divided by 4a close parenthesis plus 15. Oh, I forgot my GCF in front. Don't forget that. 3b. Then we're dividing by 15ab over 3b plus -9b squared over 3b. And this is why you had to learn those rules of exponents. So we have 4a, 20 divided by 4 is 5, A cancels, so I'm left with an A. Then plus negative 12 divided by 4 is negative 3. And then the A's cancel, so I'm left with a B. So you want to be very careful there. Then plus 3B, parenthesis, 15 divided by 3 is 5. The B's cancel, I'm left with an A. Plus negative 9 divided by 3 is negative 3. And then a B's cancel. And so we're left with, in parentheses, 5a plus negative 3b. That matches, so that's our first factor, 5a minus 3b. And then the second one is what's in front, 4a plus 3b. So you can use this even if you don't have only one variable. You can have two variables, and this still works. Now let's look at this one. We've got t squared minus 44. We don't have that middle term. So what helps here is to put it as a 0. That helps out a lot if you want to use the AC method. So it's t squared plus 0t plus negative 144. So you've got it in the same format. You just had to put a 0 there. So a times c is going to be negative 144 because the number in front of the t squared is 1. And if you want, you can even write that number in to kind of help you out. I think I grabbed the wrong color. There we go. So we're multiplying 1 times negative 144. And then we're adding to 0. So I'm going to write down 1 times 144, 2 times 72, 144 divided by 3, 3 times 48, 144 divided by 4, that's 4 times 36, doesn't divide by 5, divided by 6, 6 times 24, divide by 7, decimal, divided by 8 is 18, divided by 9, 9 times 16, 10 is decimal, 11 is decimal, and then 12 is going to give you 12, and then you start kind of going back and repeating the process. So they're multiplying to a negative 144. We need to have opposite signs, one positive, one negative. And the only possible way for them to add to 0 is if they are the same numbers. So there's only one choice here. They have to be the same numbers for them to add to be 0. One positive, one negative, they cancel out. So it's a 12 and a negative 12. So I've got t squared plus 12t plus negative 12t plus negative 144. So instead of writing the 0t, we now have 12t and negative 12t. So I'm going to group them. And my greatest common factor is just t in the first one. And then I can divide a negative 12 out of the second. So I've got t, and I'm going to just skip the step where I write the division. I'm going to just do it in my head. I'm removing a t from each term, which leaves me with a t plus 12. Then I have plus negative 12, and then I divide negative 12 from each term, and that gives me t plus 12. So now in parentheses, we have the same thing, t plus 12. So that's our binomial factor. So that's in front. And then in the back, we have t minus 12. And so that's how you can factor something where you have no middle term. You basically artificially put in a 0, and then you can make it work and you can use the AC method. Now I have one last example to give you. Negative 8x squared plus 51x plus 18. So 51 divided by 3 times 17. So there's no greatest common factor other than maybe a -1. I can factor a -1 out of there because there's a negative in front, but there's no number that goes into 8, 51, and 18. So when we factor out a -1, you're just switching the signs. So that's going to be 8x squared minus 51x minus 18. And we do that just because we want to have the first term with the squared part be positive. So now I'm going to take 8 times negative 18. So 8 times c is 8 times negative 18. And that gives me negative 144. So we just went through writing all of those numbers. You know, we saw all of those. There was 1 times 144. I wish I could just, oops, copy and paste it. 2 times 72. 3 times, I think it was 48. I should actually double check that rather than trying to remember. Okay, yeah, and then divided by 4 was 36, was it? 4 times 36, and 6 times 30, and then we had 8 times 18, 9 times 16, and then 10 and 11, and then 12 times 12. So same list we had before. We're multiplying to a negative. The middle term is negative, so we need to make the big number negative. And now we're looking for the combination that will get us to negative 51. So 1 minus negative 144 is negative 143. 2 minus 72 is negative 70. 3 minus 48, negative 45. And you can see we missed it. We went from negative 70 to negative 45. And if I continue trying to find these, the numbers are just going to keep getting smaller, negative 32. And this is because of the way that I set it up. So you can write down every single combination here and do the math. That gives you negative 24, negative 10, negative 7, and 0. None of these give us 51. None of them give us negative 51. And it's not a problem that we put like the sign in the wrong place. What this means is if you've gone through 8 times c, you wrote down every possible combination that multiplies to that, you've got your signs in the right place, and none of them work, that tells you that what you were trying to factor was prime. So this part cannot be factored. And we call that prime. So your answer is the step that you stopped at. Negative 1 times 8x squared minus 51x minus 18. We tried to factor using the AC method. We can't go any further. So that's just our final answer because that's as far as it goes. There's no other way to factor that. So that is the AC method in a nutshell. I strongly recommend printing this off, having it handy so that way you can follow these steps every single time. I've shown you how to write the factoring by grouping part. We've got lots of examples here, and you should be able to follow it, you know, with all of this. You've seen lots of examples. So this should be good. If you have any questions, you know how to reach me. Hopefully this was helpful.